Okay, greetings once again, guys, and welcome to another edition by iCampSA. In this edition, we are looking at a trigonometry problem where we are required to simplify this expression without using a calculator. So let's go to the next page and have a look at how we can simplify this. So if you remember, what we are given is the following. So we're given sine of 40 degrees, then times cos of 40 degrees, and all of this is divided by sine of 100 degrees. Okay, so there's a couple of things that we can do in order for us to solve this problem. And the first thing that I need you to remember is the following. So I need you to remember what you covered under the section where you were doing double angles, because this will be very important. So let's look at cos. If you're given a double angle of cos, maybe let's start with sine. If you are given sine of 2 theta, this can be written as 2 sine of theta, and then cos of theta. Then secondly, if you're given cos of 2 theta, this can be written as cos squared theta minus sine squared theta. It can also be written as 2 cos squared theta minus 1, but it can also be written as 1 minus 2 sine squared theta. Okay, very important, double angles. Then what I want to remind you also, as part of this quick revision, it is what we call co-ratios. And with co-ratios, what we are saying is that if you have cos of 90 degrees minus theta, this will always be equal to sine of theta. So as long as the two angles, that is this angle and that, as long as they add up to 180 degrees, what we have is a co-ratio. Sorry, as long as they add up to 90 degrees. So we can do exactly the same when we are looking at sine. So sine of 90 degrees minus theta, it will just change to a cos of theta. And what you should observe is noted, this angle and this angle, as long as they add up to 90 degrees, these will always be equal. Okay. So with all that said, let's go and have a look at our problem. And there's two ways we can solve this problem. So the first thing, I'm going to look at the top. I can see that I have a 40 and a 40. Okay. Then we look at the bottom. I have a sine of 100. So if you think carefully, when you look at the top, I have sine of 40 degrees. So if I want, I can write this as cos of 50 degrees. Why can I write this as cos of 50 degrees? It is because this angle plus that angle do give us the 90 degrees. So that is co-ratios. Okay. Then if you look carefully, even the cos of 40 degrees, that we can write, if we want, as sine of 50 degrees. Okay, done with those. But then when we look at the denominator, we see that we have sine of 100 degrees. And now our question should be, is this somehow related to 50 degrees? And the answer is yes. 100 is 2 times 50. So that means what we have is sine of 2 times 50 degrees. And according to our double angle expression, this will be 2 sine of 50 degrees times cos of 50 degrees. What does this mean for our problem? It means that where we had sine of 40 degrees, we can now replace it with cos of 50 degrees times where we had cos of 40 degrees, we can now replace it with sine of 50 degrees. And our denominator, as you can see, we resolved it to be 2 sine of 50 degrees times cos of 50 degrees. And if you observe carefully, there's nice cancellation of terms here. So the sine and the sine, they cancel, and the cosine and the cosine, they cancel. That leaves our answer to be 1 over 2. So I hope this does make sense and you actually understand. So we can just finalize this and just say answer here. So it was a very easy one, but you just had to have an appreciation of the different identities. So it's sine of 40 degrees times cos of 40 divided by sine of 100 degrees. And the answer which we get is 1 over 2. I hope this does make sense and you actually understand how we solve this problem. Cheers. I hope you enjoyed.